So in these sessions, we will study about function overloading. Basically, C does not allow function overloading. So in C, we cannot have a function with same name. So this is very inconvenient because it leads to many different function definitions for the same functionalities. So assume that you want to develop function for calculating average value of two numbers. So one function receives two int value, like this one, and another function receives two double values, like this one. But since the C does not allow same name functions for different functions, you have to give different names to these functions. And the typical workaround is to append postfix to indicating the types of parameters. So here we put D here because this function receives two double types of arguments. And here we put the I postfix values because this function receives two types of arguments. So doing this, we can make the function name different to each other. So this is a typical workaround we used in the C programming language. But in this case, you need to remember all the function names. So you need to remember there is a function name average D for receiving two double types of arguments, and average I, which receive the two parameter types int, and so on. So you have to remember all the function names, and you have to use appropriate function depending on the types of arguments. This is very inconvenient, but it is much more convenient if we can use the same function name regardless of the type of the arguments. So function overloading comes in C++. So in C++, new feature is introduced, which is a function overloading. Function overloading is a feature of programming language that allows many functions with same name, but with different signatures. So what is signatures? The function signature is the function's name with the type of parameters. So this is a function signature. So return type is not included in the function signature, so you have to remember that. And the function signature must be unique. So two overloaded functions must not have the same function signatures. So if you look at this below, these are the function signatures. Function name is here, AVG. And the types of parameter list are here, shown here. So these are the function signatures. So let's play with some kids. So do you think these two functions have the same signatures? Think about this for 5 seconds. This is a quiz. Okay, the answer is these two functions has the same signature because its name is same and its type of the parameter is same and the number of the parameter is same. So these two functions has the same function signatures, even though the name of the parameter is different because function signatures do not include the name of the parameters. So how about these two? Do you think these two functions have a same function signatures? Think about this one for 5 seconds. Okay, the answer is no. These two functions has two different function signatures. Even though these two functions have the same name, but the number of parameter list is different. This one is 2 and this one is 3. So number of parameter list is different. And also the type of parameter is different. This one is double and this one is int. So these two functions have two different function signatures. Then how about these two, the second and third one. Do you think these two second and third functions have different function signatures or the same function signatures? Think about these 5 seconds. Okay, so this is a little bit confusing, but these two function signatures are same. You might think these two function signatures are different because the return type is different. The first one is returning int, the second one is returning double. But as I said earlier, that return type is not included in the function signature. So this is not part of the function signature. So you only have to look at this part. And if you look at this part, the name of the function is same, and the number of parameters is same, and also the type of parameter is same. So these two functions has a same function signature. But if you look at the second and fourth functions, do you think these two functions have a same function signatures? I don't think so, because even though these two functions has a same number of parameters list, but the types of second parameter is different. The second one is a int type. The fourth one is a double type. So because the type of parameter is different, these two functions has two different function signatures. Okay, so we talk about the function signatures. So bear in mind that when you overloading the functions, when you're overloading two functions, the function has to have two different function signatures. So function cannot be overloaded if two functions have the same function signatures. Okay, so let's see the concrete example of overloading functions. So here we have two functions of the same name, average, which performs the same task, but with different number of arguments. The first function receives 2 arguments and computes the average of these 2 numbers. The second function receives 3 arguments and computes the average of these 3 numbers. These two functions have a different function signature because the number of parameters is different. This one is 2 and this one is 3. So these two have a different function signatures. So this is example of function overloading. In this example, we overloaded function name average. In C, this is impossible because C does not allow 2 different functions to have the same name, even though the number of parameters is different. So this is only allowed in C++, not in C. And because of this, we can now make function call with same name, but with different number of parameters, which is much better approach than using the 2 different function names. So you can call average like this one and this one. So here the number of parameters is 2. So this function call will execute these functions. And here this function call passes 3 arguments. So this function call will execute these functions. So this is much more convenient. So compiler will automatically resolve these invocations, function invocation, based on the signatures of function call and select appropriate function to execute. So if the compiler cannot resolve the function invocation due to some of the ambiguities, the compiler will throw error message. Then how compiler resolve the function invocations and find right functions to execute? First, the compiler looks for the exact match of signatures. So if you assume that there is a function mpg with 2 double types of parameters, the signature of this function call is exactly matched to these function signatures. because it's passing two double types of arguments, and this function signature receive two parameters with types of double. So this function call exactly matches to these functions. So compiler will execute these functions for this function call. If the compiler cannot find the exact match of the signatures, for example, this case, here we are making function call, function name is MPG, but we are passing two parameter arguments, but type int of two arguments. But as you can see here, this function received the double types of parameters. So this function called signature does not exactly match to these function signatures. But since there is no MPG function which receive two int types of parameters, compiler looks for a compatible match where automatic type conversion is possible. So for this function call, compiler automatically converts 5 and 20 to double type and execute this MPG function with two converted double types of arguments because there is no exact match of signatures. So similar for this case, because there is no MPG function with one int type and one double types of parameters, compiler automatically converts first int type of parameter to double type and then call these MPG functions. Let's see the demo code for function overloading very quickly. Okay. Okay, so let me first compile this code. And execute it to see the output. So if you look at this program code, there is three MPG functions. The first one received two double types of arguments, and second one received two int types of arguments, and the third one received one int type and one double types. And in main function, we call MPG functions like this way. So if you run this program, it prints the II and 0.25 first, and then ID and 0.200803. This is because this first function call, because 5 and 20 is int type, compiler resolve this function call and executes these functions because this function receives two int types. So that is the reason why the program prints II here. And for the second one, it passes first int type of argument and the second the double type of argument. So the compiler executes these functions. So that is the reason why this program print ID here. So this is how the function overload work. We can call the functions with the same name, unlike the C. So this is very convenient. Okay, so let's go back to the slides. Okay, we've very quickly saw the example code for function overloading, which is this one. So what are the ambiguity situations in function overloading? So I said that compiler will throw error message if there is an ambiguity in function overloading. So let's talk about the ambiguity using example code. So if you look at here, there is 3 f functions. The first one received int types and double types of arguments, and the second function received double type and int type of arguments, and the third one received 2 int types of arguments. So if we look at this function call, it's very obvious that this function's call will execute the function number 3 functions, this one, because this number 3 functions receive 2 int type of arguments. 98 and 99 is int type, so this function call will execute the third functions. Second one is also straightforward because the first argument is double type and second one is an int type. This function call will execute the second function because the second function receives double types and the int type of arguments. How about the third one? Which functions will compiler will execute for this function call? This function call passes 2 double types of parameters, arguments, but as you can see here, there is no function f which receives 2 double types of parameters. So what function call, what functions will be executed by this function call? Think about this for about 10 seconds. Try to find the answer. Okay, so let's run this code and see the program output. So this is exactly the same code we just saw. Here we have 3f functions. The first one received int and double type, and second one received double and int type of parameter, and third one received 2 int type of parameters. And we call f function like this way. It is very obvious that first and second function call will execute, for this one, it will execute the third one, and this one will execute the second one, because it's an exact match of the function signature. Let's see this first, whether the output is as expected. As you can see here, the first function call prints 3 because this function is executed, and the second function call prints 2 because this function is executed as expected. Now our question is this one. Which function will be selected by compiler to be executed? So let's compile this and run this one. As you can see here, if we try to compile this program, if compiler throw error message saying that call to f is ambiguous. Because this function call is ambiguous, compiler throws error message. So why this is ambiguous? Let's go back to the slides. Okay, so this function call is ambiguous because compiler does not know which functions to execute. So for example, the compiler does not know, because as you can see here, there is no f function with receiving two double types of parameters. So there is no exact match of function signature. So compiler looks for the functions for the compatible match. So if we go back to few slides, so there is two rules for compilers for selecting right functions. So as you can see here, the first one is an exact match of signature, but as you can see, there was no exact match of function signature. So the compiler looks for the compatible types of functions where automatic type conversion is possible. So here, compiler tried to convert the first one, the double types, to int one. Then the first function can be executed, because if we convert this to int, then this function call is type int and type double. So this function matches. But if compiler try to convert the second argument to int type, so this one is double and this one is int, the second function can be selected to be executed because second function receives double and int. So depending on whether the first, whether the compiler convert the first arguments or the second arguments, the different functions can be selected to be executed. So there is an ambiguity here. Compiler don't know which arguments to be converted. So compiler throw error message, as we just saw using the demo code. So you should avoid such ambiguity when you are overloading functions in your program. Okay, so in these sessions, we talk about the function overloading in C++. So we said that C does not allow function overloading. So in C, we cannot have a function with the same name, but we can have a same function name with function overloading in C++. And we also talk about the overloading resolution rules. Compiler first find the exact match of the function signatures. And if there is no exact match of function signature, it looks for the compatible types where automatic conversion is possible. And we also talk about the ambiguity in overloading, which leads to the compiler errors. Okay, so that's it for these sessions. See you in next sessions.